Thank you. For those of you who I have not had the pleasure to meet, Sarah Hamidai, I am an associate professor of resiliency planning in the sustainability division in SoMAS. And I have the great pleasure today to introduce my wonderful colleague and friend, Dr. Miyuki Hino from the Department of Urban and Regional Planning at UNC Chapel Hill. Dr. Hino is an expert in studying natural hazards, but with a really interesting interdisciplinary lens of looking at measuring the impacts of climate change in the form of extreme events and hazards, looking at the intersection of climate change impacts, natural hazards with policy and governance, and measuring at various spatial scales how these extreme events, including flooding, which she's going to present on today, affect people, economies, and communities. She has a really interesting, fascinating interdisciplinary background in terms of her training and work. Her work on looking at evidence-based climate policy studies, and her training both at Stanford and before that doing an engineering degree in chemical engineering at Yale. She has worked in environmental resources and climate studies throughout her postdoc, PhD, and undergraduate training. Without any more further ado, let's hear from Miyuki about the impacts of chronic coastal flooding in North Carolina. Thank you.
Thanks so much, Sarah, for that very kind introduction, and thanks for the invitation to be here. I wish I could be there in person, but fortunately, Zoom is better than nothing. So I'm really excited to get to share with this kind of broader, more interdisciplinary audience about this work that we've been doing on chronic coastal flooding in North Carolina. It does touch on, as Sarah said, a lot of different dimensions of the work that I do, both to measure the hazards themselves, as well as the impact on people, communities, and businesses. I'll be presenting like a portfolio of projects that we call the Sunny Day Flooding Project. And it involves a really big team who I want to acknowledge here. My main kind of co-conspirator on this work is Dr. Catherine Anardi. She's at NC State. She's a coastal engineer. And we've got a really fantastic team of students and other faculty research collaborators, both at our institutions and in Hawaii, where we're sort of expanding into. And we also could not do this work without our community partners. And so we've got really fantastic community partners here and in Hawaii who help us do our work. Right. So, as many of you know, up in coastal New York, coastal flooding is occurring in the absence of extreme events due to sea level rise. And essentially, we have coastal infrastructure like roads and stormwater systems that were built decades or even centuries ago, and they were designed for the water levels at the time. And as sea levels have risen over time, we now have routine fluctuations in water level due to very high tides or due to wind. Those used to occur with no disruption at all to coastal infrastructure systems, but now they're occurring on top of higher average sea levels. And so we're seeing flooded roads, flooded drainage systems, and so forth on a much more routine basis due to these water level fluctuations. We study how often these happen, generally using tide gauge data. So here's a schematic of how a tide gauge might capture one of these events, where you've got the tide gauge out over the ocean, over the body of water, and it's measuring water levels here. In this case, the marine water levels are high. They've backed up into the stormwater drain and are coming out onto the road. And often what the data we use to study this type of thing is there's a flood threshold designated at each tide gauge. And when the water levels go above that at the tide gauge, that is what we tend to call a high tide flood day. And that's based purely on what the tide gauge is measuring. So this is an example from NOAA that does a great job tracking how these high tide flood days have evolved over time. So this is an example for the Beaufort tide gauge here in North Carolina, where they're tracking, anywhere from 5 to 10 high tide flood days per year over the last few decades. They also have projections of how high tide flood day frequency might change over time under different sea level rise scenarios. And of course, we're projecting an acceleration under all sea level rise scenarios. And in the case of these kind of intermediate and higher ranges, we hit, literally every day becomes a high tide flood day by the latter half near the end of the century. So these high tide flood days are generally the indicator we use to think about how often coastal flooding is happening. But that's problematic because tide gauges are actually not intended to capture all sources of flooding. Tide gauges were designed to measure water levels in the ocean. And so there might be flooding on land that isn't being captured at all by a tide gauge. And that's because, for example, in this picture, you could have flooding from rainfall at a moderate tide. So here we have a marine water level that's not super high, so it's not above this flood threshold, but it's backing up into the storm drain. So when rain falls, that water has nowhere to go. And we still have flooding on land, even though we don't have a flood kind of triggered at the tide gauge. Groundwater, faulty infrastructure, those impacts are not going to be picked up at a tide gauge because that's just not what tide gauges were designed to do. The other challenge with tide gauges is that they're sparse. There's not very many of them, and they tend to be located in more urban areas. So the entire state of North Carolina has 4 that are managed by NOAA. And of course, the farther you get from a tide gauge, the less information is available to you about how often this type of coastal flooding might be happening. So in this project, we are trying to understand both the incidence and the impacts of chronic coastal flooding. And today I'll walk through 3 branches of this work. The first is how often it's flooding on land and what the drivers of that flooding are. So we have deployed a sensor network in flood hotspots and are measuring flooding through those. Second, I'll talk about the impacts on coastal residents, both collected through household surveys and through water quality testing. And then finally, I'll talk about ongoing work helping communities try to understand and prioritize strategies for adapting to sea level rise and mitigate flooding. So I will start with this first component on how often it's flooding on land. So when we talk about chronic coastal flooding, we're talking about flooding that is much smaller in scale and much shorter in duration than flooding that you would think about from a hurricane or from a major kind of, think about atmospheric rivers on the West Coast. That's not what we're talking about here. The example on the left, the animation you're seeing is flooding during an extremely high tide at one of our sensor locations. It's a sunny day flood. It is purely due to high tides. And it, we're talking about maybe a part of a neighborhood, several city blocks. They tend to last for minutes to hours. And they have many flood drivers. And so on the right is a picture of a rainy day flood, where rain and tide combined to cause this kind of flooding at another one of our locations. And so we want to measure flooding that is smaller in scale, shorter in time period, and can be caused by all sorts of different drivers in combination. And as we talked about, tide gauges don't really do this. And so we developed a new sensor to try to capture flooding from all of these different sources. And there are 2 parts of this. One part is a pressure logger that sits inside a storm drain, or in rural areas, it sits in like the drainage ditch that's right next to the road. That picks up water levels as they back up into the storm drain and push out onto the road. And that's paired with a communications gateway and camera. And so the camera is taking pictures of the road, and the gateway is relaying the pictures and the water level measurements from the pressure sensor in real time every 6 minutes. So the advantage of our setup is that if we have high marine water levels that are backing up into the storm drain and causing flooding, we're going to detect that. But we're also going to detect flooding that comes from other sources. So in that example of a moderate tide plus rain, our pressure sensor is still going to be picking up the water levels that are on the road, and we're going to capture that. And because we're measuring every 6 minutes, we can capture flood events that are very short. They can be short and small in spatial extent, and we'll still pick them up if our sensor is wet. So this is what they look like in real life. This is the pressure sensor I talked about. It's attached to the grate here, and so that flips back down onto the storm drain, and the pressure sensor hangs down into the catchment. And then up here is the camera and gateway that are taking pictures of the road and then relaying all the information in real time. We have about 10 of these out across the state now. The earliest were deployed in 2021, and the latest just probably about 6 to 8 months ago. In most of our communities, we have multiple. In some, we have just one. So the first thing we did with our very first tide gauge, which was in Beaufort, North Carolina, is we wanted to see how our measurements were comparing to what the tide gauge was picking up. And Beaufort was a great location for this because it's less than a mile away from a NOAA tide gauge. And so we actually have a sensor in this storm drain where my mouse is right here. And on the right here is a plot of the water levels that we are measuring in the storm drain, that's in blue, and the water levels measured at the tide gauge, which are in pink. Those are the NOAA observed water levels. And the animation is actually showing this peak right here, where the blue star is. So you can tell, you can barely see the blue line under the pink line because these match each other perfectly, right? The NOAA tide gauge is picking up this increase and decrease in water levels extremely well. This was also reassuring to us because it meant that our sensor was working properly and measuring the right water levels. And so in this case of a sunny day flood event, that tide gauge is doing a really good job at capturing the water levels coming up above the road and then back down. However, we also saw that during rainy day events, we were seeing really significant deviations from the tide gauge water level, where we were capturing floods that the tide gauge would not have captured. So this is similar. So this pink again is the NOAA tide gauge water level, and then now our water level from the storm drain is in black. And you see during this time period that they are kind of mimicking each other pretty well. And then once you get rain, so rain is shown in this top plot, you're seeing these big spikes, these deviations where the storm drain is seeing spikes in water levels that are not being captured at the tide gauge because it's due to rainfall. And so this picture, it's hard to see, but there actually is flooding right here. And this is one example of that kind of combination event that we're going to pick up that a tide gauge wouldn't. So having seen this in Beaufort, we then said, okay, let's look across multiple of our sites and look at what NOAA is reporting in these high tide flood days. And actually, the National Weather Service also has a threshold for minor flooding, and we can also compare our estimates against the National Weather Service minor threshold. Like, let's see how those things compare and whether these tide gauge-based proxies that we use, that I have used, that many other researchers have used, how do those compare to actual flooding? And so in Beaufort, we're talking 5 to 10 flood days a year, and we looked through our data and looked at a year, and we found 20 days of flooding in Beaufort, 60 days of flooding in Carolina Beach, and 122 days of flooding at sea level. So that's over the course of 1 year, where we define a flood as any amount of standing water on the road outside of extreme storm events. So we actually took a handful of days out of this because they were associated with a tropical storm. Of course, any amount of water means it could be a very small amount or it could be much deeper. We felt that one, because it's often saltwater, and saltwater in any volume is bad for infrastructure and for cars, that any water made sense. The other side of this is that you could probably justify any threshold you wanted for how deep it has to be a flood. And so just to keep things simple, we said, all right, if there's any amount of water, we're going to call that a flood day. And we see many more flood days than the tide gauges based on the NOAA thresholds would suggest. So here in this light green bar is the number of high tide flood days. So that's what's reported here by NOAA over the same time period for our data. For Beaufort and sea level, that number is, I think, 9 or 10. And sea level is also very close to the Beaufort gauge. The Beaufort gauge is the closest to sea level, so we use that gauge for both locations. In Carolina Beach, the Wilmington gauge, which is the closest, only had one high tide flood day over that time period. In medium blue are exceedances of the National Weather Service's minor threshold. So these are also based at the tide gauge, but the National Weather Service has a different threshold than NOAA does. And so the National Weather Service has a lower threshold. So you see more National Weather Service flood days in Beaufort, way more at Carolina Beach. And again, the same here as in sea level, because we're using the Beaufort gauge. So then the dark blue line, the dark blue bars are our sensors, which we shorthand refer to our Sunny Day Flooding Project as Sunny D sensors. And so in Beaufort, I told you we tallied about 20 days of flooding. That's much more than the NOAA high tide flood days, but actually a little bit less than the National Weather Service. In Carolina Beach, we had 60 or so flood days. That is, again, many more than the NOAA exceedances, but actually much less than the National Weather Service. And then in sea level, where we had 120 some days of flooding in our year, that's much more than either of those tide gauge based proxies would suggest. And so we are not, depending on what threshold you're using and where you are, you may be overcounting or undercounting actual flood incidents. You can also dig into this a little further and look at how, like where the mismatches are arising between what we detect as flooding on land and when when the tide gauge exceeds the high tide flood threshold. So here in Beaufort the purple dots are floods that we measured on our sensor, but there was no tide gauge high tide flood day on that day. That overlapped. And so most of the floods that we're observing, even ones that are 4 hours long, are not being picked up at all at the tide gauge. The little green triangles, the dark green triangles, are the opposite situation. So the tide gauge is going above its high tide flood threshold, but there's actually no flooding going on the street. And then these light green connected circles and triangles are instances where actually they both hit, meaning the sensor actually detected flooding and the tide gauge exceeded its high tide flood threshold. And the line is showing you the difference in duration. And so some of them are quite close, but then you've got this one on the right here where the sensor was flooding for about 4 hours and the tide gauge was exceeded for less than 1. It was probably about a 30 to 40 minute exceedance of the tide gauge threshold. And so even when the timing, even when the incidence is being captured by both, the durations are quite different, whether you're using one measure versus the other. Okay. In some of our ongoing work, and this is still very, very new and in process, we're working on using radar satellites to detect the spatial extent of this type of flood event, because one of the challenges with our sensors is that we're only measuring at one point in space. And so we can get the frequency where we are, but how frequent is it flooding 1 block away or 2 blocks away and so forth. And we're able to try to get at this because of new, very high resolution radar satellites. So we're using satellites from a company called Capella. And you can see just how detailed that data is compared to Sentinel-1, the radar that we would have been using before this existed. And so we have been tasking the satellite to go and grab our radar data at different times, depending on if we know it's flooding or not. And so here, what you can see is different snapshots from a pretty marshy area. And so this, focusing on the right, where the water level is below the road. So we know that like flooding should not be happening. The water levels are very low. And you can see kind of these bodies of water, these little creeks going through this marsh area. If you compare that to the 3 panels on the left, these are all instances of flooding of various depths. So a half foot, 1.24 feet or 1.5 feet, you can visibly see there is a big difference. And you can tell that this just looks like it's all water. You know, it looks just like this body of water, the intercoastal that's cutting through here. And so in marsh areas, there's quite clear, like there's very obvious, we can see with the naked eye changes during the high tide flood events. When we look in urban areas, so when we look in places where we tend to put our sensors where people live, it is much, much harder to see. So these are the same 4 snapshots from the satellite, just shifted further south to where there are roads and buildings, as you can see. And the images do look different, but it is much harder to tell. It's much harder to tell if there's flooding on the street or how much flooding there is on the street. And that's because of the interference from the buildings. It's because the spatial extent of the flooding is likely much smaller here than it was in the marshy area. And so we are working on using our images and sensor data as ground truth to try to refine an algorithm that can pick out and estimate what the spatial extent of flooding is at these various time steps when we know from our sensors that there was some amount of flooding happening, even in urban areas. So to sum up on this section, flood frequency on land is not accurately reflected by tide gauge-based proxies that we use a lot. And in fact, you know, for the most part, we're flooding a lot more than you would think based on those proxies. Part of this has to do with rain, stormwater infrastructure, wind, and the relative importance of those varies from place to place. All right, I'll now move to the work we're doing looking at impacts on coastal residents. We've got a lot of different pieces of this, and in the interest of time, I'm just going to focus on 2 bits. So one piece here is we've done household surveys in actually a number of different parts of North Carolina looking at who's affected and how by these kinds of floods. And so we focus this in Carolina Beach, where we have a sensor, we have several sensors. We know they flood quite regularly. And we sent this postcard out to every single address in Carolina Beach about a year ago, collected over 350 responses, and use that data to start to understand how people are being affected and especially their attitudes towards moving in relation to the flooding. We heard a very wide-ranging set of disruptions. So here they are organized just by how often respondents said, yes, I've experienced that. The most common one is trash collection disruptions. So what happens is you pull your trash bin out, it floods, the trash bin tips over and floats away, and then the tide goes out and people end up with trash up and down the street and they don't know where their trash bin is. This happens, we hear about this very often, and unsurprisingly, we also heard about that in the survey. There's a number of other things in here, water quality, health concerns from water quality, I'll come back to in a second. But I also wanted to flag concerns here about, for example, neighbors that were moving out and renting their house because of the flooding, or neighbors selling things that come back to how people think about their community and their neighborhood. And then, of course, things like difficulty obtaining insurance, lost home value, lost rental income, that people perceive this flooding to be affecting their household finances. We also asked the question, I think the exact wording of the question was, if a good opportunity arose for you and your family to move to a less flood-prone place in town, so within Carolina Beach, how likely is it that you would take it? And here I've organized our responses based on how many impacts people answered here. So for folks who said none of these things have happened to me, of course, the vast majority of them are saying 0%, that I would not move because where I am now, I'm not very affected by flooding anyway. This next panel is folks that report at least a few impact types. And so they're getting disrupted a little bit, but not really significantly. And again, most people are saying no, 0 chance, but you're seeing a little bit more of responses shifting to the right. When we go to 4 to 6 impact types, again, we're like the kind of the mass of the responses is shifting again a little bit further to the right. And then when you finally get to the folks who are most flood affected, so who are reporting 7 or more impact types that are on this list, you actually see that the most common response has shifted to being 40 to 60%. So about 50% odds that I would take this opportunity to move to a less flood-prone place in town. I think there are two very interesting takeaways from this set of results. One being more affected by this type of chronic flooding is associated with a higher likelihood of you saying you would consider moving to a less flood-prone place in town. However, even people who are extremely affected by flooding are still, on average, saying that the odds of them taking an opportunity to move to a less flood-prone place in the town where they currently live is like 50% or less, right? You still have very few people in this category saying, oh, if I could move to a less flood-prone place in my town, I would take it. And so I think this is kind of the difference between being interested in migrating and actually moving, is that we can start to see this shift in interest, perhaps, right? Going from 0% to more like 50% as the flooding gets worse. But the flooding being bad is still not enough to shift many people from 0 to 100% or even 20 to 80%. And so there is an association here. There is like an increased willingness of folks to consider moving, but it may not materialize in actually an increased rate of moving because it's just not quite there yet. And so we're also teasing this out through more in-depth interviews, and we are definitely seeing people talking about this and talking about moving out, but whether we see that in, for example, real estate data is still an open question. All right. So the second piece on impacts that I want to talk about is in relation to water quality. And so we have collaborated with 2 faculty at NC State to look at the water quality in the tidal flooding and understand if it poses any kind of threat to health. And the concern here is that you could have sewage lines that run underground. And if those pipes are leaky or in any way compromised, the sewage might be rising. And when you have a flood that comes back through the stormwater pipes and up, it's essentially mobilizing that sewage and bringing it up to the surface. And in the case of these tidal floods, you actually very regularly see people walking their dogs through the water. You see kids playing in the puddles. And so the nature of the potential water quality concerns could extend to health problems for people who are exposed. So Megan Card, Dr. Natalie Nelson's PhD student, did a sampling campaign where we sampled along each of these road intersections when there was flooding, as well as where the stormwater outfalls come out to the yacht basin, the intercoastal here, and sampled for the fecal indicator bacteria, Enterococcus. Floodwaters are not regulated. So I think that's very important to emphasize is that there is no regulatory standard for floodwaters. What we're showing here as 100 is the recreational standard. So that's the standard, for example, if you're going swimming at a beach or a lake and it's higher than 100, most probable number is MPN, then there will be warnings, or in some cases, it'll be shut down where you can't swim in those waters. Based on our sampling in Carolina Beach of the floodwaters at each of these intersections, all of them exceeded that 100 threshold at some point. We did 8 sampling campaigns in total, and the averages are not that different than what you see from these 3. So all of the sites exceeded it at least once. Many of them exceeded it all 3 times, and some of them by an order of magnitude or maybe even 2. And so again, there is no regulation on floodwaters specifically. And we're currently doing work to trace the sources of the fecal indicator bacteria and understand whether it's human sources or other sources and the nature of the threat to human health. But it certainly is true that there's reason for concern here, especially because people interact with this type of water quite regularly compared to, for example, flooding that happens during hurricanes. You don't generally see people splashing in the puddles, although you may, but hopefully it doesn't happen as often as we see this type of interaction with tidal flooding. All right, let me check the time. We've got a little bit longer. So for impacts on coastal residents, these impacts are very widespread. In another survey that we did in North Carolina that was actually just a random sample among coastal communities, 40% of people said that their property flooded outside of hurricane events. And that wasn't even trying to identify the people that lived in low-lying areas. So this is much more common, I think, than we had realized it was. The disruptions are quite widespread, and there are potentially very severe health concerns associated with exposure to these floods. All right, so I'll wrap up here by talking about some of our ongoing work engaging communities in trying to identify and evaluate adaptation measures. Our first effort, which is nearly done now, is we brought together a group of about 15 to 20 residents of Carolina Beach in a series of workshops. And we started last June. And in last June, what we did was we did a big brainstorm. We said, all right, let's talk about what strategies are potentially of interest, are potentially helpful, where could they be implemented? We're not ruling anything out. Let's get all of our ideas out. So that generated a long list of potential strategies. I'll show in a second. We then went and modeled the effectiveness of those strategies under current conditions, both for marine-only events, meaning tide or tide plus wind, versus compound events with rain, and how the effectiveness differed across those different drivers. We used that to narrow down the list, or I should say the residents used that information to narrow down their list of what they thought was appealing and good to evaluate. We then reported back to them on how the strategies perform under future sea levels and other feasibility-related factors like cost, timeline, in some cases, legality. And then have emerged from that workshop, which was a few months ago, with a small number, about 3 strategies that are most of interest to them. And what we're going back in a couple months to do is to do a reflection on the process. We have what we're sharing back with the community, which is all of the results that we came up with, but also, okay, if you want to move forward with this strategy, these are the next steps we recommend you take. As well as a public-facing opportunity for folks who are not part of the workshop but want to engage. So I want to highlight especially how we did this evaluation, because I think this is where a lot of the benefit of the interdisciplinary collaboration came through here, is one of Catherine Nardi's PhD students, Thomas Thielen, used our sensor data to develop and validate a very local flood model for this area. And he essentially could replicate, once we were confident that he could replicate a number of different events that we had seen in the past, we used that model to then evaluate the effectiveness of the strategies that folks were coming to us with. So this is an example of an event from January 2023, I think, where this is tides and wind forcing. On the far left, tides and wind forcing under present day sea levels. You can see water kind of comes through this vacant lot and floods this intersection. The water kind of runs south this way. One of the strategies that was mentioned to us very often was we need higher bulkheads. We need one higher continuous bulkhead that runs all the way along this kind of channel. And so we modeled that. We put that into the topography, and we said, okay, under present day sea levels, with tides and wind only, with these higher bulkheads, that's very effective. We see no water, right? No water coming through that low-lying vacant lot, no water on the street. We can also say, okay, what about under higher sea levels? And so in that third workshop, we modeled effectiveness under sea levels all the way out to 2100. And what you see at 2050 is already at that point, the water finds a way, right? The water in this case is actually coming through the marshy area well north of what we're showing, and it's propagating down. So even though you have those higher bulkheads, it's actually, you needed to bulkhead even more than the area that we had designated in order to keep the water out. And of course, we can also then, in addition to tides and wind, we can add in rain. And so this last panel here is showing if you have your higher bulkheads, but you also have rain causing some of the flooding, even under present day sea levels, the bulkheads are not helping with that flooding. And in fact, they're keeping the water in, right? They're making it harder for the rain to drain out. And so you get even worse flooding than you would without the bulkheads when you have rain. And so these are the types of results that we were showing for not just bulkheads, but also a range of other different land use changes and floodgates and those types of different strategies that folks came to us with, and basically handed them the results and said, okay, you make of this what you want, and then tell us how your preferences and your thoughts and your evaluations on these are changing. We're about to start doing this in a very different form in a much more rural conservative part of North Carolina. And the way we started the engagement process there was we had 2 PhD students actually live there last summer doing interviews. And the data they collected was they did a mapping exercise with their interviewees to identify important places in their network, whether it was work, church, grocery store, friends' houses, and so forth, identified which of those were experiencing flooding, which is in blue, and also identified stretches of road that were flood prone, that people identified as this is really problematic when this floods. And this one stretch, the North River Bridge, was mentioned almost all the time. And so what we're doing next is we're developing a flood model. And one of our goals is to really to kind of zoom in on our flood model results in the places that were identified to us as being really important and being really flood prone, so that we make sure that we're giving information back to folks that is meaningful and important to them. Okay, great. So just to summarize and wrap up and turn over to questions. We look at how often it's flooding on land. It's flooding much more than the tide gauges would indicate. And part of that is just because there are many more drivers causing flooding on land than are being captured at the tide gauges. People in kind of much larger regions than we would expect are being affected by this in lots of different ways. And I think there are some emerging new problems, for example, with these health concerns that require a lot more further investigation, potentially new ways of regulating and intervening in those settings. In terms of how we can try to turn this into movement and action forward, we're working with affected communities, our partners, to try to identify what those adaptations are that are consistent with the things that they care about, that are consistent with priorities for their community, and use what we can do and our technical expertise to evaluate their effectiveness and help them push forward ones that are really going to work for them today and in the future. The last thing I'll say is all of our data are publicly available in real time. So you can go to our website with the QR code or with any of these links, and you can see what the water levels are doing, what the cameras are doing. We are always happy for folks to be using our data. We're doing a big website revamp because right now our website's really slow. So if you give us like a month, you might come back to a much better, much more functional website. But in the meantime, you're welcome to poke around, and we would love to hear your feedback. All right, that's all. Thanks everybody for your time.
Yeah, maybe come up. So we're gonna first have a student question. She's coming up right now, so she'll be here.
the lights back on?
Yeah, maybe. Sorry. It's okay. Just, I think it's actually even here.
Well, thank you so much for your talk. For the Stony Day flooding sensors, you mentioned some sites only have single sensors, and I was wondering how robustly can like single sensors determine flooding at the different sites? Is there like an optimum number of sensors for this application?
That is a great question. So we actually originally thought that we were going to need many sensors in each location. And we've pulled back on that a little bit for a couple of reasons. One is just the logistical requirements. And so having a good place for the sensor and the camera, having access to the infrastructure to do that, right? We've got to work with like the energy utility or whoever it is to set it all up. That's one constraint. But the other is that like the complexity of the flood dynamics really differ from place to place. So in places where we don't have stormwater infrastructure and where it's really ditches, but water mostly flowing over land, it's not quite as complicated. So like if we know about the depth of flooding in a single place, the topography tells us a lot about what's happening in other places. Versus if we have a stormwater infrastructure mediated flood where flooding is not necessarily showing up in exactly where you think and it's going through pipes rather than over land, then those are the instances where we tend to have multiple in one place. And so how many you need to understand the dynamics, I think really differs based on the context. But having said that, a lot of the motivation for the remote sensing is recognizing that like what the sensors can tell us is quite limited about spatial extent. And so if we want to cover more territory, then we need different ways to do that. And so hopefully some of the radar data can help with that.
Awesome. Thank you so much. Thank you. Okay, we have a second student who's gonna ask your question.
Thank you for your presentation. And my question is that the data collected from the sensor you just able to utilize to build some models to predict the future floods, like when it will come and how strong it is? Yeah.
Yes, the short answer to your question is yes. So for example, those last couple of images I showed of like modeled flood extents with and without bulkheads or under future sea levels versus today, those were, that was a model built by a PhD student using the data from the sensors. And so he used the data from the sensors to understand, to kind of validate and tune the model in addition to other data, right? So tide gauge data, wind data, rain data to understand the different forcers at any given moment in time. That model also has every stormwater, like the stormwater pipes and the outfalls and all the connectivity in that. And so it was, it's very local because it requires so much detail in that place. But once you have a model like that, and actually in another one of our communities, it's a less detailed model because there isn't stormwater drainage infrastructure. But once you have a model like that, then we can do things like, what about under future sea levels? How often is this going to happen? What if we had heavier rain with a strong wind from a certain direction? You can decompose the drivers once you've kind of developed a model that you feel can accurately recreate what's going on in the given location.
Yeah, thank you.
Thank you. Do we have questions on Zoom? Okay. It's in the chat. Do you want me to read it for you, or do you see it?
I see it. I guess I can summarize it quickly. So whether the household surveys or focus groups ask about how people are already managing flooding and how it fits into other community concerns of points of pride, how strong are community ties, and what kinds of local relationships exist. Okay, yes. So in all of our surveys, we also ask about managing flooding, responding to flooding, either at households or community scales. So we ask both, like, what have you done? Have you made any changes to your property? Do you do things like change, right? Lots of people are like, I just like make sure I like look at the tide calendar and then I go to the grocery store when I know it's low tide. So we hear stuff like that about how people are managing flooding. And we also ask about, like, have they engaged in community conversations or planning efforts about hazard mitigation and resilience. So we do ask about those things. I think certainly in like the very last thing I mentioned, where we did in that more rural Carteret County area, where we got people's kind of networks of like, where do you go and what places are flooding and what problems you have. A lot of those which were less structured, that was a very lightly structured interview protocol. And that picked up a lot of like, I remember one person introduced themselves and said, you know, I'm 74 years old, I'm from sea level, I'm not moving. Like, that was his way of introducing himself. And lots of content there on choosing to stay, what it would mean to move, what futures they want for their community and what they care about. And so James Collins, who's the PhD student who's leading that, has been coding and analyzing the interviews for those themes. And it's interesting because we do have a variety of settings. Like, we've got a more urban, touristy, like small town, you know, we've got a range from kind of small cities to very rural, and more touristy to much less touristy. And we certainly see big differences in like community ties and attachment to like the local culture between those locations. And so the migration questions that I reported on here were from a place where actually there's like less of a super strong cultural identification than some of our other places. And I'm sure the data in those other places would not look the way that the stuff that I showed you did. I'm sure that would just be like, it doesn't even matter how often I'm flooding, I'm not moving.
Thank you. Oh, we have another question in the room. I think you may have to come up to just because there's no microphone.
Okay. Hi. I have a bunch of questions.
How about two?
Okay, wait, let me pick. Okay, two important questions. Prior to this study, like, were there any policies that were in place that were observed regarding these specific like flooding issues? And like, if so, like, how do they vary before you conducted the study and like after? Like, did you see any like actual like actionable changes?
Let me think. So there's really only one of our partner communities where the local government does anything about flooding. And in that town, they post warnings specifically for very high tide events. They will like send warnings out via Facebook, but they also have a flood gate. They have a gate that they lower to cut off the road when it floods and when it doesn't flood. Sorry, when it floods, they close it. When it dries out, they reopen it. And that's because people were getting very upset with people driving through and splashing salt water onto their houses and lawns. And so they don't want people to do that. That they do that. I mean, it's changed a little bit in the sense that that town now uses our website and our cameras to figure out what's going on and whether they need to go out there and close or reopen things. So it's made things a little bit more efficient for them. Whereas before they would have someone just like sit out there for hours just in case. But it hasn't, I think one of the goals of the community workshops is to give them kind of a nudge in the right direction of what type of action, they can move forward with that would be supported by the community, because there's a lot of frustration there about inaction. In the other places, there really aren't responses to this at all. So essentially the road just floods. And if you're stuck inside your house for a few hours, you're stuck inside your house for a few hours, and that's it. And I think part of our goal is to encourage local governments, regional councils, and even to some extent the state level to think about addressing this more directly, and being a little bit more proactive about how they respond to and plan for adaptation in these locations.
Thank you. And then my second question was like, you showed a graph, I believe, for the tide gauge reports for like NOAA and compared to like the sensor. So I was wondering, why do you think the tide gauge is reporting flooding if there isn't any actual flooding happening? It was like the green triangle in the graph. So I was wondering, like, what do you think that specific reasoning is for?
Yes, great question. So in some places, so in Beaufort that I showed, the town of Beaufort installed a backflow preventer into their stormwater pipe. So what that is it's like the stormwater pipe is going out this way, and they put something inside it that is intended to not let water come back through and up, but it does let water out the other way. That backflow preventer works sometimes and does not work sometimes. And we are working with them to try to help them understand why it works sometimes and why it doesn't. But I expect that in those dark green triangles, I think what was happening is that the backflow preventer was actually working. So the water levels in the Taylor's Creek in the ocean were actually very high, but that infrastructure was successfully preventing the water from backflowing into the system and onto the road. In other places, we see that just because the tide gauge is not co-located with the sensor. And so, for example, in sea level, we see lots of those events because the water levels just vary across, they're really different 10 miles away than they are at the tide gauge. And wind is affecting water levels and flooding differently at a sensor location 10 miles away than it is at the tide gauge. And those very local deviations in water level, the tide gauge can't pick those up because the tide gauges only are where they are. So I think some of it is variations in marine water levels over small distances, and some of it is local infrastructure.
Okay, thank you.
Thank you. I had the same question. Good job. Do we have any other questions? See anybody else raising their hand or in the chat? Then Miyuki, thank you so much for this really, really interesting presentation. Maybe you can stay on just a few minutes, then Sarah can also.
I do have a couple of questions,
Oh.
but I will send them later.
Yes.
I wanted to take advantage of these few minutes we have to say a really heartfelt big thanks to Miyuki for sharing this project with us, sharing this presentation. And I just wanted to highlight how inspiring it is to see such an action-oriented research that is the opposite of extractive. They are collecting all of this data, but very quickly they are doing all of this on the ground engagement with the community to understand how all of this is impacting people on the ground, their concerns about housing values, insurance, health. And they have these workshops that each one of them are a ton of work to put together. And I say this from this experience of a tiny bit of experience of trying to do that elsewhere. It's really, really encouraging and inspiring to see how they are going from this truly interdisciplinary research project with public health components, with real estate components, with flood modeling, you name it, all of these amazing researchers coming together and in the same project, taking it to the communities, doing these workshops with them to figure out actual solutions. I truly appreciated that. I also wanted to, with this thank you, remind everybody in the all hands SoMAS reminders I sent, I did say, if you want to connect and ask other questions from Professor Hino, please reach out. I am more than happy to connect you. And I am sure all of you found this study as fascinating as I did. So hopefully there will be continued conversations. Miyuki also put in the chat that she will share the slides with me. I will share with everybody. Just reach out and we can do that very quickly and easily. Thank you again. Please help me in thanking Professor Hino.
Thanks so much, Sarah.